Alright, hello, and this is the first of my 5 videos. And in this article was titled "The Sun is Stranger Than Astrophysicists Imagined," and it deals with astrophysicists recently observing the sun and finding that it emits a lot more gamma rays and in a lot odder frequencies than previously believed. So, using the Fermi telescope about a month ago, astrophysicists found that the sun emits 7 times more gamma radiation than previously thought. However, the amount of gamma rays, a small sliver of frequency, is just left absent in this amount. At around 10 trillion hertz, there's simply a drop-off, which usually doesn't happen in nature, where just randomly no light is emitted at that specific frequency, but it happened, so scientists are particularly stumped by that. So, the theory behind why the sun emits gamma rays in the first place is actually not from the sun itself. It's actually from a reaction between the sun's magnetic field, and a bunch of supercharged hot gas particles around the sun and cosmic rays that hit the sun. So here I'm drawing a little model of the sun right here. And these cosmic rays that hit the sun are actually just supercharged protons that are zooming through space and eventually hit the sun. When they're going through space and get close to the sun's magnetic field starts to affect them, because since protons have a positive charge and the sun's magnetic field has both negative and positive charge, the protons are actually sometimes turned around in a process called mirroring. They get closer and closer and closer until the magnetic field is strong enough to overcome their velocity, and it instantly changes their direction, and instead of going towards the sun, they instead get shot back. However, within this redirection of the photon, or of these protons, sometimes they get close enough to reach the sun's extremely hot, gaseous field around it, which is a lot closer to the sun than is its magnetic field. When the protons are unable to be stopped and mirrored by their sun's magnetic field before they reach this little gas cloud, they'll be mirrored and then collide with some of the super hot electron particles here. And since the proton is positive and the electron is negative and they're both traveling super high speeds with super high energies, upon collision they annihilate each other, and then we will get our gamma rays, which are launched off instead of a proton or a super hot electron in the sun's cloud. Now, this theory was thought up in 1991 by scientists David Seckel, Todor Stanev, and Thomas Geisner, and it's been the most widely accepted theory and seems to still hold true today, but the calculations they made seem to have been a little bit off. The Fermi telescope detected 7 times as many of these gamma rays, with increasing strength as the frequencies went up, which is a lot more than what Seckel, Stanev, and Geisner previously thought. As the frequencies increase, the efficiency rate of this conversion of fast-moving protons to gamma rays gets stronger as well, up to about 20 times stronger, and at the highest frequencies it can even be an 100% conversion rate. So, some new theories to explain this have popped up as well, such as one of the odder ones being that there may be dark matter in the sun that may annihilate other dark matter particles, generating gamma rays, but this has been generally quickly shot down because as the gamma rays are traveling through the physical matter of the sun, they sort of get refracted and then toned down to normal frequency light, or something lower than that, such as microwaves. So, in order to check this out, The scientists did experiments on this and have been looking at the sun, observing what it does, and have been trying to point some new other telescopes at the sun in order to see what happens. Jack Cologne, a heliospheric physicist at the University of Arizona, decides that this gaseous field right here is the corona of the sun, and that the corona is what mostly creates these extremely efficient conversions from protons to gamma rays. Now, it seems that these conversions aren't completely consistent across the sun's field, though, and it seems that they change in from year to year during the sun's 11-year cycle, in which the polarities of the sun right here, so say this one right here would be, let's call this positive, and this one down here, let's call this negative. Every 11 years, the sun's polarities will actually flip, and positive would then be negative and negative positive. So as the sun undergoes this little flip here of polarities, it seems that depending on what state it is in this flip, the gamma rays conversion will actually change. So this is just no real experiment actually occurred in this thing. It was more of an observation and sort of a tip-off to other scientists to say, hey, look at this. This is really odd. There's a lot more gamma rays than we previously thought in our own solar system. And there are still some inexplicable things that I don't really understand. Like, they haven't been able to explain this huge dip in frequencies that they were talking about, which they say is around 10 trillion hertz, which is already really huge enough as is. But it seems that once it hits that 10 trillion hertz range, there's just no gamma rays or frequency there, which is kind of odd, and that's one of the questions I have about it. And I also want to know how might that affect us, because gamma rays are some ridiculously strong uh, frequency of light, so how aren't we like being fried like fish down here on Earth if there's 7 times more gamma rays than previously thought hurling towards Earth? So as far as that goes, that was my very first, I don't know, article that I read. Thank you.